use the inverse of matrix A to solve the following system. So the fact that we're being asked to use the inverse of matrix A means that we need to use the following theorem. So recall that if A is an n by n invertible matrix, then for every vector B in Rn, the non-homogeneous equation has a unique solution. And that unique solution is defined as vector x is equal to the inverse of matrix A times vector B. So in order to use this theorem, the first thing that we need to do is convert this linear system to the homogeneous or the non-homogeneous equation. So let's think about what we are given here. We have the system of linear equations 8 times x sub 1 plus 5 times x sub 2 equals negative 9. And our second equation is minus 7 times x sub 1 minus 5 times x sub 2 is equal to 11. So we know that this linear system is equivalent to the following matrix equation. So we have the 2 by 2 matrix A, 8, 5, negative 7, negative 5. So there's matrix A multiplied by the vector x in R2. So it has two entries, x sub 1, x sub 2. And this is equal to the constant vector, or your scalar valued vector, negative 9, 11. So we can see that therefore, matrix A is a 2 by 2 matrix. Again, that's 8, 5, negative 7, negative 5. And we know that we need the inverse of this matrix to solve this system. So let's define these entries. So let this be the 2 by 2 matrix with entries A, B, C, D. So next, we need to find the inverse of matrix A. So we need to find A inverse. So to do that, we need the determinant. So we know that the determinant of matrix A is defined by the quantity A times D minus B times C. So we have 8 times negative 5 is minus 40, minus negative 7 times 5 is minus 35. So we have 40 plus 35, or negative 40 plus 35. And so we can say that therefore the determinant of matrix A is equal to negative 5, which does not equal 0. So we know that matrix A is invertible, meaning that we can use that 2 by 2 definition to find the inverse of this matrix, and then be able to use that to find the solution x. So we know that the formula for the inverse of matrix A is defined as 1 by the determinant of matrix A multiplied by the 2 by 2 matrix D minus B minus C A. So this will be negative 1/5 multiplied by the 2 by 2 matrix, and we'll have negative 5, positive 7, 8. And distributing that scalar multiple through, we have that the inverse of matrix A is equal to the 2 by 2 matrix, whose entries are 1, 1, negative 7/5, negative 8/5. All right, so now we have all of the pieces that we need. We have the inverse, and we are given vector B to start. So we're ready to find vector x. And again, by this theorem, we know that the solution vector, vector x, is defined as the inverse of matrix A multiplied by the constant vector B. So here we go. We have vector x is equal to the 2 by 2 matrix, 1, 1, negative 7/5, negative 8/5. And we are multiplying this by the constant vector, negative 9, 11. So here we can use either the formal definition for matrix vector multiplication, or you can use the dot product, the row column rule for matrix vector multiplication. So I'm going to use the row column rule. So we have the first row of the inverse of matrix A multiplied by vector B, So we have negative 9 plus 11. And then we have the second row of the inverse of matrix A multiplied by vector B. So that is leaving us with positive 63 fifths minus 88 fifths. Well, at least we have a common denominator. So 9 plus 11 leaves us with 2. And then we have 63 minus 88, which leaves us with minus 25 fifths. Ooh, lucky us. And so, therefore, vector x is equal to the vector 2, negative 5. Now, before we box this up and assume that this is the correct answer, we want to make sure that we double check so that we get 100 on our quiz or exam. So we just want to make sure that if we take this vector x we just found above and multiply it by the given matrix A, is this going to in fact equal vector B? I don't know. Let's find out. So the given matrix A again was 8, negative 7, 5, negative 5. And we are now multiplying this by what we just found. So that is 2, negative 5. So here we go. By the row column rule, we have the first row of A times vector x leaves us with 16 minus 25. Then the second row of A multiplied by vector B, by vector x, is negative 14 plus 25. So 16 minus 25 leaves us with negative 9. And then 25 minus 14 leaves us with 11. Which is vector B. Woohoo! So this confirms that, yes, what we found above is, in fact, our beautiful final answer. Now, as you are probably noticing, this is not necessarily the most efficient way to solve for vector x. It's going to be, more often than not, much quicker and easier to simply use row reduction of the equivalent augmented matrix. However, when we're working with 2 by 2 matrices, especially by hand, this method of using vector x defined as the inverse of matrix A equals vector B is going to prove to be a useful method.